Okay, at the top of your notes, please write properties of rational exponents. Properties of rational exponents. Okay, everything we go over today was actually taught to you by your Algebra 1-2 teacher, whether that was during 0 hour, maybe with Miss Castro, or possibly even like in 8th grade at Castro Estrella or whatever middle school you went to. So really this is stuff that's already been taught to you, but it's a refresher. And I found out in my earlier periods that some kids already felt like they knew it, and other kids felt like they never had been taught this. So it's a good review time. All right, here we go. So we're going to go through there's one rule here, and it's a rule of exponents. And this is what the rule says. So please write down this first example. If we are going to examine example number 1, we'd see that these two had different faces, the same exponent, we're multiplying, and then afterwards we're going to raise it to the power of -5. So here's how the rule works. This only works when you're multiplying or dividing and when you have the exact same exponent. Only works when you're multiplying or dividing and you have the same exponent. So what we're going to do is we are going to perform the operation it asks you to do. So 8 times 2 is 16. Now, reapply the exponent that you pulled away. And I have 16 to the 1/4 raised to the -5 power. We're evaluating here. We're not solving. When you evaluate the inside of the brackets, 16 to the 1/4 power, that means what times itself? 4 times equals 16. The answer is 2. Now this comes a part that's a little more confusing for students, and it kind of depends how your teacher explained it to you. There's multiple ways to explain it, and I'll get the same answer. I explain it like this. Think of this as having a top and a bottom. So 1 times whatever's on top and 1 times whatever's on the bottom. This one is happy, not because it's positive, because its exponent is positive. This number 1 is happy because its exponent is happy. This portion is not happy because the exponent's not happy. So I'm going to move it from the top to the bottom. And when it moves down to the bottom, the exponent now becomes happy. 2 to the 5th is not 10 like some students think. It means 2 times 2 times 2 times 2 times 2, which is 32. Final answer is 1 divided by 32. Write down example number 2. Before I go over example 2, notice that the beginning example for the first one was in rational exponent form. So now it's in radical exponent form, and if you prefer to rewrite this, you can. So 4 to the 1/3 times 16 to the 1/3. These are equivalent forms. Again, as long as you have multiplying or dividing and you have the exact same exponents, we can perform the operation. 4 times 16 is 64. 64 to the 1/3. What times itself 3 times equals 64? Anyone? 4. Problem's done. So we've done it with multiplying. Now we're going to do it dividing. Write down example number 3. As a quick reminder, in example number 2, some students automatically call these square roots. These are not square roots, they're called cube roots. Cube root. This is a square root because what's hiding here? The number 2. So if you like The radical form, feel free to leave it in this form. Otherwise, you can rewrite it as well. As long as you're multiplying or dividing, you guys done? As long as you're multiplying or dividing, perform this operation. 48 divided by 3 is 16. Now bring the 1/2 back. What times itself 2 times gives you 16? And the answer is 4. The next one's going to be with your partner. Okay, go up to the side and please take, no, let me help you with this one actually. Take 320 and divide it by 5 off the side, long division. Don't use a calculator. I'm going to give you 15 seconds, go. Do long division. Sounds like, oh crap, I hate doing long division. Maybe your 2nd grade sister can help you, right? Or 3rd grade brother. Does 5 go into 3?
Yeah.
No. Does 5 go into 32?
Yes.
How many times without going over? 6. Multiply, subtract, bring down. How many times is 5 going to 20? 4 times. Okay, so this is 64. So as long as you're multiplying or dividing and you have the same exponent, you can perform the operation. There's a couple ways to go about doing this, by the way. One way is to continue to do the inside out. So what times itself 6 times gives you 64? Does anybody know? It's 2. Again, this 2 is not happy. Currently it's on top. 1's happy, 2 is not. So the 2 is going to go down to the bottom. When it goes to the bottom, it is now happy. 2 times 2 is 4. Final answer is 1/4. Turn to your partner, whoever's taller. I'd like you to explain either 3 or 4. It's your choice. Go ahead. 3 or 4, it's your choice. Go ahead. Paige, we're good? All right, here's your last concept. Now, I've spoken to Ms. Castro, and she said that they're no longer testing this at the Algebra 1 level. They expect students to know it in 8th grade. So I'm going to call on Pedro and Fernanda to see actually if they remember doing this, okay? So nobody else answer, because we assume that you already learned, even if you forgot. We're going to call on Pedro and Fernanda. You ready? Simplify this for me. Everybody else be listening. We're going to go over their answers. What do you think it is, Pedro? 2 times 5 squared. Do you agree with that? Oh, cube. Oh, square root. Oh my gosh, Pedro. How are you in this class? Do you agree or disagree with that, Fernanda, or are you like lost? You agree. Turn to your partner. Pedro was right. Now, there's some like little side work to get to this point, but see if you and your partner can remember how. So I recall this is how my algebra teacher taught me. Again, what number is hiding here? 2. So watch real quick. Remember, as a mathematician, you want to do the least amount of work. So here's how you start. Ready? Please listen. 1 times 1 is 1. Well, 1 never simplifies anything. Then 2 times 2 is 4. Can 4 nicely divide into 20? Okay, we're trying to find a perfect square that nicely divides into 20. So I learned doing like this tree thing. So you break it apart, there's your 4. 4 times 5 is 20. The square root of 4 is 2, remains in front, and square root of 5 is back, and we're done. Can you raise your hand if you remember doing this, 8th or 9th grade? Some of us yes, some of us no. Okay. So we're going to do the same thing, but now we're going to do it with fractions and also with different numbers other than squares. So if I gave you this one, now we're going to list perfect cubes. So 1 times 1 times 1. And then 2. 2 times 2 times 2 is 8. 3 times 3 times 3. Remember, we want to stop. We want to do the least amount of work. 1 never will simplify anything. Does 8 divide nicely into 32? How many times? 4. So your perfect cube stays in front. You answered with 4. What is the cube root of 8? Problem done. All right, you're going to do the next one with your partner. I'll give you 30 seconds and then I'll go over it with you. Go ahead. Please talk through this with your partner. All right, here we go. So, 1. Does 8 go into 54? No. What about 27? 27 times 2. So the cube root of 27 is 3. And here's your final answer. Can I have a 1 through 5, how well you're understanding this concept? Okay, so here's where it gets a little difficult. So hopefully you remember, let's just do a quick review. One of these fractions is okay, the other one breaks a major math rule. Servando, what is this answer? And what is this answer? 0. So this is 2 and this is 0, okay? Tell me how you come up with 2 here. Okay, what do you think it is? Let Servando answer. Okay, better question. Okay, how about this? Give me that answer. 5. So watch this. Watch me work backwards. Do you agree 3 times 5 equals 15? So when you figure out this answer, think to yourself, ready? What number can you take times 0 and it equals 2? Nothing. There's no answer. This doesn't exist. There's no solution to this problem. And then is 2 times 0 equal to 0? So the way I remember it is if 0 is on top, you're good to go. So this is good to go. But if 0 is on the bottom, you're in trouble. It doesn't work. Okay, got that? So this is the math rule. You can't break this math rule. Well, there's another math rule. So back in 8th grade, how many of you remember this? Your teacher said you can't leave a square root on the bottom. Hands up high if you remember that. And then I think they used to do this. Times the square root of 2 times the square root of 2, and then your final answer would be like that. Do you guys remember anything like that? No, yes? Like a couple of us? Okay, so another math rule you're learning right now is you cannot leave a radical in the denominator. That means nothing that looks like this. Remember, we're not going to call it a square root anymore because that's a specific type of radical. You can't leave a radical in the bottom. So here's how this works. Here's your first one. Really not that hard of a concept, okay? So the first thing we look at is we look at what is the nth root. That means what is this number? And the number is 3. So I'm immediately going to think in my head, or I'm going to write down perfect cubes. So 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. And as I go, remember, as a mathematician, you want to do the least amount of work. So here's what you're thinking. Is there a number that I can take times 3 and easily end up with 1? Well, there is a number, but it's a fraction, so we don't want to do that. Is there a number I can take times 3 and get 1 easily? No. Is there a number I can take times 3 and easily get 8? No. Is there a number I can take times 3 and easily get 27? That number is? So we're only focused on the denominator because we can't have a radical in the denominator. Take whatever is times the bottom, also times the top. I'm going to break it apart. What is the cube root of 27? That means what times itself 3 times gives you 27? 3. This problem is done. We no longer have a radical in the denominator. All right, next. So focus on the nth root, which happens to be 4. And whether you write down the numbers, bless you, Jasmine, whether you write down the numbers or you think of it in your head is totally up to you. So 1, is there something I can take times 8 and easily get 1? What's the next number, Nick? So I received 1 by taking 1 times 1 times 1 times 1 4 times. What's the next number that goes here, Nick? 16. So Nick, is there an easy number I can take times 8 and achieve 16? So whatever you do to the bottom, do it to the top as well. Break it apart. Sons, what is the 4th root of 16? 2. Problem is done. Pedro, do you have a question? Good to go? Thumbs up or thumbs down whether you understand the concept right now. Okay.